Thought for the day. Prabh kya simran nahi jam tarasa. In the remembrance of God, there is no fear of that. Prabh kya simran puran asa. In the remembrance of God, hopes are fulfilled. Prabh kya simran man ki mal jaye. In the remembrance of God, the filth of the mind is removed. Amrit naam rid mahe samaye. The ambrosial name, the name of the Lord, is absorbed in the heart. Solidstate, Part 6, Imperfection in Solids by Amrik Singh, PGT Chemistry. Imperfection in crystalline solids or crystal defects. Irregularity in the arrangement of constituent particles in solid is called imperfection in solid. We have already studied this, and point defect, line defect, we know this topic, and there is point defect only in our syllabus. Stoichiometric defect and impurity defect are already completed. Today we are going to discuss non-stoichiometric defect. It is a type of point defect which disturbs the stoichiometry of solid. Metal, it is of three types: metal excess defect due to anion vacancies, metal excess defect due to the presence of extra cations at interstitial site, and metal deficiency defects. Non-stoichiometric defects. Defects because of presence of constituent particle in non-stoichiometric ratio in the crystal structure are called non-stoichiometric defects. Non-stoichiometric defects is mainly of two types: metal excess defects and metal deficiency defects. Metal excess defects are of two types. First one is metal excess defect due to anionic vacancies. These type of defects seen because of missing of an ion from regular site, leaving a hole which is occupied by electron to maintain the electrical neutrality of the compound. Hole occupied by electron is called epicenter and responsible for showing color by the compound. This defect is common in NaCl, KCl and Si and LiCl. Diagram showing a metal excess defect due to anionic vacancies. First of all, we are creating a ideal crystal. Suppose it is of NaCl maybe, and crystal is constituting here, and positive, negative, repeating here. One is positive, other is negative, -1 plus 1, -1 plus 1. Now, the anion leaves its position and its position is occupied by electron called epicenter. Hole occupied by electron is called epicenter. Therefore, it is the kind of metal excess defect in which an ion leaves the lattice site and its position is occupied by the electron called epicenter as shown in the diagram. For example, sodium atoms get deposited on the surface of crystal when sodium chloride is heated in an atmosphere of sodium vapor. We have these sodium vapors, and we have sodium chloride crystal in the blue box, and sodium chloride crystal and sodium vapors. Sodium atoms diffuse on the surface of the crystal in point second. In point first, it is shown that sodium ion diffuses on the surface of the crystal. And second point, in this process, chloride ion get diffused with sodium ion to form sodium chloride. Chloride negative ion, these chloride ions move toward the sodium atom, and sodium atom removes electrons, and electrons take the position of chloride ions, and in this way the anion leave the crystal and comes onto the surface, and it is a kind of metal excess defect in practical. In this process, sodium atom, let us see the language. In this process, sodium atom releases electron to form an sodium ion. This released electron get diffused and occupies the anionic site in the crystal of sodium chloride, creating an ionic vacancy and resulting in the excess of sodium metal. The anionic site occupied by unpaired electron is called epicenter again. When visible light fall over the crystal of NaCl, the unpaired electron present gets excited because of absorption of energy and impart yellow color. Because of the similar defect, if present, crystal of LiCl impart pink color and KCl impart violet color. And second one is the metal excess defect due to the presence of extra cation at interstitial sites. Zinc oxide loses oxygen on heating, resulting the number of cations zinc ion become more than the anion present in the zinc oxide. As shown by the equation, ZnO is heated, delta is shown heating, it is changes into Zn2 positive, oxygen is removed and 2 electrons are free in this process. The excess cation Zn2 positive and move to the interstitial site and electron move to the neighboring interstitial site. Because of this, zinc oxide impart yellow color when heated. Such defects are called metal excess defects. As shown in the diagram, we are constituting a ideal crystal first. Zn2 positive and O2 negative are shown as negative is in blue here, and ideal crystal is constituting we here, and again positive negative 2 positive 2 negative 2 positive 2 negative 2 negative 2 positive, and this is the ideal crystal. Zn2 positive leave the uh, 2 negative oxygen leaves the crystal when heated in the form of O2. It releases 2 electrons, okay, and electron goes on interstitial site in the same as shown. The Zn2 positive takes another interstitial site as shown in the diagram. Now third one is metal deficiency defect. When metal present less than the ideal stoichiometric proportion of the solid, it is called metal deficiency defect. Such defects are shown generally by transition elements. The less portion of metal is compensated by some metal having higher valency. Thus, when metal present less than the ideal stoichiometric proportion in a crystal, it is called metal deficiency defect. Example, FeO is generally found in composition Fe.950. In the crystal, FeO missing Fe2 positive ion are compensated with Fe3 positive ion in order to maintain the neutrality. Let us see with the help of a diagram, and we are constituting a first ideal crystal here, and 2 negative 2 negative 2 negative 2 positive 2 positive 2 positive 2 positive, one row we more constitute here, 2 negative 2 negative 2 negative 2 negative 2. Now we see in place of 2 positive there is Fe3 positive here, and other position also in place of Fe2 positive taken by Fe3 positive, and for these two substitution one Fe2 positive vacancy is created. This is shown blinking +2 +3, again showing +2 +3 blinking. And now some homework from NCERT textbook. 11 questions are there with answers. Thank you for watching the lecture.